Alright, let's talk about redox reaction. Now, the easiest way to remember your redox vocabulary is to remember the acronym of oil, Rig. So, oxidation is loss of electrons. Reduction is gain of electrons. So when you're thinking about losing and gaining electrons, you have to think back to previous knowledge and remember that when you have a neutral atom, say we have an atom that has a singular proton and it has one little tiny electron around it. Okay? This is the atom form for like hydrogen. Now, hydrogen can do two things. Hydrogen can actually get another electron from somebody else, add it to its outer ring, so that then it has become a hydrogen -1 ion. It is a -1 charge because, please remember that each electron carries a -1 charge. So if our electrons are giving us, there's 2 of them, so that's a -2. We have 1 proton in the center, so that's a +1, for an overall charge of this ion being -1. So when an atom becomes a negative anion, yay vocabulary, then the charge is negative. So you have to get in your brain that the gain of electrons causes the ion to be negative. So reduction is gain. But if I had the same hydrogen atom that has 1 proton and it's 1 little electron, and say someone comes along and plucks off that electron, so then this hydrogen is just a little proton with no little electrons. It doesn't have any negative electrons. It has an overall charge of +1 just from the proton. So it has lost electrons. This particular hydrogen atom has undergone oxidation. Now, your textbook gives you some rules for recognizing the oxidation numbers. So, some general tips to remember is that oxygen is awesome, and oxygen is highly electronegative. And because it is highly electronegative, it will generally become a negative ion. And remember, when it becomes a negative ion, it gains electrons, so oxygen will generally undergo reduction. Your highly electronegative elements will trump. They will undergo reduction. They will gain the electrons. Because remember, electronegativity is the ability of an atom to attract electrons, to gain electrons, and so the higher the electronegativity, the better it is at attracting electrons, and that means it's going to be the better oxidizing agent, better at undergoing reduction. So realize oxygen is almost always a -2 unless it's in the peroxide polyatomic ion, the O2 that had originally crossed down -2. Each oxygen inside this is a -1. Otherwise, oxygen is always -2. Also remember that your neutral elements, so any atomic element or diatomic molecule, is always going to have a charge of 0. You have a full list of these common rules in your textbook and in your notes from class. And the list of common rules for oxidation numbers can be found anywhere on the internet. I'm not going to write those out for you. Now, let's look at some practice problems to assign oxidation numbers. So, if you're giving the compound of Na2Se CO3. And I ask you to assign oxidation numbers for each element. Realize, oxygen, each oxygen is going to be a -2. Well, there's 3 of those, so it's really accounting for a -6 portion. Now, on your rule sheet, it tells you that metals, especially group 1, group 2, or group 3 metals, will always do their regular charge like we use in ionic bonding. So sodium is a group 1 metal, so each sodium is going to be a +1 charge. So there's 2 of those, so this sodium area, if you split the compound, is accounting for a total of +2. And since this is a neutral compound, if this side is -6, this side is +2, to make a neutral overall 0, the selenium in this case must be a +4 charge. All we're doing is assigning oxidation. Realize you have to think of individual atoms, not just the oxygen. The whole oxygen part isn't -2. The whole oxygen part is -6. Each oxygen has a -2 charge. If we look at another one, so if we look at H3BO3, each oxygen is a -2 times 3, total portion -6. Each hydrogen here, hydrogen is generally going to be +1. It can be -1, but since we already have a highly electronegative oxygen, then your hydrogen is going to be the positive ion. So it's a +1 times 3, so this is accounting for +3. So if we know the oxygen is each -2, we know hydrogen's +1 each. That means this boron, in order to balance this -6 and +3, will have to also be a +3. So assigning oxidation numbers shouldn't be that tricky. This summarizes the 2 skills. Well, the first skill you need to be able to look at oxidation redox. The second skill is a little more vocabulary. So realize that oxidation and reduction happen at the same time. So oxidation is loss. So you lose electrons, so you become positive ion. Okay, reduction is where you gain electrons, so that means that you became negative in terms of ions. Now, your oxidation lost electrons that were gained by the reduction. So we can say that what undergoes oxidation, so if it undergoes oxidation, then it was the reducing agent. But in opposite, if it undergoes reduction, then it was the oxidizing agent. And you have to think about it this way. If it undergoes reduction, it gained electrons. When it gained electrons, it caused something else to be oxidized because oxidation is lost. So let's look at some of this labeling within some examples. So whenever you're given an equation and you're asked to decide what is being oxidized, what is being reduced, what is the oxidation agent, what is the reduction agent, first thing you need to do is assign oxidation numbers so you can see what's going on. So this phosphorus is atomic phosphorus, so it's going to have an oxidation number of 0. Chlorine is also 0. But when they became a compound, this is a compound, but notice that, well, chlorine is very electronegative. It is much more electronegative than phosphorus, and I know that because chlorine is farther to the right on the periodic table. So chlorine is going to be my negative ion former. So I know that each of these chlorines is a -1. This -1 is really representing a total of -3 because there are 3 of those. And since there's -3 from the chlorine, then this phosphorus must be a positive 3. So notice the phosphorus went from a 0 to a positive 3, meaning that my phosphorus went from being neutral to having 3 less electrons than normal. So it lost 3 electrons. But the chlorine went from 0 to negative 1. And each individual chlorine gained 1 electron. So if I remember my oil rig acronym, I can easily see that since oil represents oxidation is lost, that phosphorus was oxidized because it lost electrons to become a positive 3 charge. Chlorine underwent reduction because it gained electrons. Now, remember, they kind of flip with the vocabulary, so if phosphorus oxidized, that means phosphorus was the reducing agent. Since chlorine was reduced, it is the reducing agent. Vocabulary, vocabulary, vocabulary. So if we look at the second example, we start by assigning our oxidation numbers. So in this case, we have a total of each oxygen being a negative 2, because oxygen is more electronegative than chlorine. It's higher up. And this is really 3 of those. That's really a total of negative 6. So if this is negative 6 and has the overall negative 1, then this chlorine must be a positive 5. Because positive 5 plus negative 6 is negative 1, which is the overall charge on that species. And this one, we again have O, and it is more electronegative than the arsenic. So we have a negative 2 times 2, which is really representing negative 4. So in order to have a negative 1 charged overall, this AS would have to be a positive 3. Now when I come over here, I have again an oxygen. There's 4 of them this time, so negative 2 times 4 would give me negative 8. But each individual oxygen is still negative 2. But notice I need to have a negative 3 overall charge. So negative 8 plus 5 would give me negative 3, meaning this particular AS is a positive 5. And this chlorine is a negative 1 charge. So notice our oxygens in all 3 species are negative 2. The actual oxidation for oxygen did not change, so I really don't care about oxygen. I'm not looking at oxygen. What I'm looking at is the fact that chlorine went from being a plus 5 to being a negative 1. And realize that if it's in terms of electrons, when it's a plus 5, that means that the chlorine had 5 less electrons than it needed to have. So if it has 5 less electrons, in order to get to the point where it has 1 extra electron, which is the meaning of a negative 1 charge, chlorine had to gain 6 electrons to get from positive 5 to negative 1. Think number line. And the AS went from being a positive 3 to be a positive 5. This means that when it's a positive 3, it had 3 less electrons than protons. It had 3 more protons. But then it had 2. A difference of 2. So this means this AS, to go from positive 3 to positive 5, that means that this AS had to lose, so it lost 2 electrons. And this isn't a balanced equation, and we can see that it's not balanced due to the electrons lost not equaling the electrons gained, and we'll deal with balancing that in the next section. But in this section, we're just asked to decide who's being oxidized, who's being reduced, and use their vocabulary. So since chlorine gained electrons, and we know that reduction is gain, thanks to the rig portion, we know that chlorine was reduced. If chlorine was reduced, that means it was causing the oxidation. Since the AS lost electrons and oxidation is lost, and the AS would be would have been oxidized, making it the reducing agent.